To figure out if two lines are parallel or perpendicular, we have to compare their slopes. Parallel lines will always have slopes that are the same number. They're the same steepness, they never intersect, so they're parallel. And there's your symbol for parallel if you don't want to write it down each time. Perpendicular lines are going to be lines that have slopes that are opposites, meaning one's positive and one's negative, and are also reciprocals, meaning they are fractions that have been flipped around. So we have to make sure both parts of that is true to be perpendicular, opposite signs and reciprocals. And then if neither of those things are true, then those lines are just nothing. They're just two lines that intersect. So first up, they've given us two slopes. M is slope. I can see my slopes are 1 and -1. So they're not going to be parallel because they're not the same number. To be perpendicular, remember, they need to be opposites, which they are. I have a positive and I have a negative, so that's good. And then we also check if they're reciprocals. Well, since it's not a fraction really to start with, I can write it as a fraction if I choose to. I can write it as 1 over 1 and -1 over 1. And 1's an interesting number. It's the only number that's its own reciprocal. If I were to flip 1 over 1 around, it would still be 1 over 1. So again, my definition to be perpendicular, I need to have opposite signs. I've got that. One's positive, one's negative. I have to have lines that are fractions that are reciprocals, and since one's its own reciprocal, I have that, meaning these two lines must be perpendicular to each other. Compare that over to the second example where they try to trick you. I can see right away the lines are not parallel. One's a half and one's 2 or 2 over 1, so they're not the same number. They're not going to be perpendicular, or they're not going to be parallel, but then I want to check if they're perpendicular, and I can see they're reciprocals. If I flip 2 over 1 or 1 over 2 around, I get 2 over 1. My other fraction. So I might be tempted to say that, okay, they're reciprocals, these lines are perpendicular, but remember there were two things that had to be true. I also had to have signs that were opposite, and I can see that they're both positive, so unfortunately they're not opposite of each other. So these lines are not perpendicular, they're nothing. They're just two lines that intersect, they're not parallel, they're not perpendicular either. What you'll probably see more of are problems like this third one, where we actually have to go and calculate a slope first, and then figure out if the lines are parallel or perpendicular. So I'm going to go ahead and do that, the y1 minus y2 over x1 minus x2 formulas. If you want to pause the video and try that for yourself, if you're not good with slope, you might want to do that. Otherwise, I'm going to just have my work pop up real quick, and then we'll take a look at the two slopes we get. So there's the two slopes I need to compare. The first line was 3 over -2, or -3/2. The second line has a slope of 2/3. Make sure you simplify it. I can see again they're not parallel, they're not the same number. To be perpendicular, two things must be true. I got to check first, are they opposites? Is one positive and one's negative? If you said yes right now, you're right, and also weird for talking to a video. But the other thing I had to check for is, are they reciprocals, meaning can I take one fraction and flip it and get the other one? Well, if I flip 3 over 2 around, I get 2 over 3, which, yes, is my other fraction, so they are reciprocals as well, meaning these two lines are perpendicular to each other.